Again, welcome to Unit 1, Part 1 lectures. This is College Algebra course. And today our main objective is to review the basic algebra, and we are going to cover the set of real numbers. So what is a real numbers? Again, this is a College Algebra course. So here we're going to identify set of real numbers, also identify properties of real numbers, and also graph a subset of real numbers on the number line. So first, a set of real numbers. Here we say a set is a collection of objects. An example would be dishes, or set of golf clubs, or a set of shirts, clothes. So a set is a collection of objects, and it can be any type of object. Now we also have example here, the set of vowels in English language can be denoted as A, E, I, O, U. These are again vowels in English language. So here we say that in every member of one set B is also a member of another set A. Then we say that B is a subset of A. So what we mean here is that if we have any member or any item in set B, and that items are also in set A, then we can say that set B is a subset of set A. And normally we use a symbol as C underline. So this will be read as a subset of. So example here will be B is a subset of A. B is a subset of A. So if A and B are two sets, we can also form a new set consists of all the members of both sets A and B. And normally we refer this as the union of A and B. So the union of set A and B means all the elements in both sets are now a new set. So a union of A and B means every element in A and also every element in B combined together. There's no repetition. So we can denote this set by writing A union B. A union B. Now, if we have two sets, let's say A and B, and we can create a new set, which we will call A intersect B. A intersect B, which means we only need all the elements that are in both A and B. That are in both A and B. So we can see the difference between union and intersection. Union means all the elements in A and also all the elements in B combined together in one new set. Intersection means only the elements that are in both A and B are combined together as a new set. So these are some of examples. So here we say, okay, we have a set A, which have a lowercase a, E, and I. We also have set B, which have C, D, and E. We also have set V, which have the lowercase a, E, I, O, U. Now, there's a question here, is A subset of V? Well, I will look at A. So A, we have A, E, I. In order for A to be a subset of V, it means all the elements in A has to be in V also. And yes, we have A, E, I also. So our answer will be true. So the answer here is since each member of set A is also a member of set V, then A is a subset of V. Question 2, they say we should find A union B. So I'll look, A, we have lowercase a, E, I. B, we have C, D, E. So A union B will be A, E, I, C, and D. So here B, we said the union of set A and set B contains the members of set A, set B, or both. So the answer will be A, C, D, E, I. So these elements are in both A and also in B. Intersection means we want to look for only the elements that are common in both A and B. And when we look here in A and B, we have only E, sorry, E. There's E in B and there's also E in A. So in the intersection of A and B will be only E. Now, if there's no element common, then we say intersection of A and B is 0 or empty. So the term we learn here is what is a subset? A subset V means all the elements in A, they are also in V. Find A union B means we want to find a new set where we have all the elements in A and also all the elements in B in that new set. A intersect B means we want to find only the elements that are common in both A and B. So next, we're going to identify set of real numbers. So here we say there are several sets of numbers that we use in everyday life. For example, we have a natural numbers, we have a whole numbers, and also we have integers. So a natural numbers will be counting such as 1, 2, 3, 4, 5, 6. The whole numbers, now the difference is this, a whole numbers normally is a set of natural numbers also, but including 0. So we can see that in natural numbers, excluding 0, there's no 0. Then integers can be negative, 0, and positive numbers. So integer will be a set of whole numbers and they are negatives also. In a natural number, we don't include a negative. Also, we say two important subsets of the natural numbers are the prime and also composite numbers. And we know a prime number is a number that its factors are only the number itself and also 1. So which means it's divisible by 1 and itself. So a very simple example would be 2. 2 is a prime number because 2 is only divisible by 1 and the number itself, which is 2. Or 19 is a prime number because it's only divisible by 1 and 19. Or we can say the factors of 19 will be only 1 and 19. Composite numbers can have more than 2 factors. So prime number is only 2, the number itself and 1. But let's say, for example, if we have 4, 1 and 4 is okay, but also we have 2. So this does not make it a prime number, rather a composite number. For example, 20 can give us 1 and 20, but also to give us 5, it also give us 4, it also give us 2, it also give us 10. All these numbers are divisible. And when we say divisible means when we divide the 20 by all these numbers, the remainder will be 0. So they are divisible. We also have a set of even numbers, which means 10, 8, 6. So it can be positive or negative, etc. Odd numbers means when we divide the number by 2, the remainder shouldn't be 0, at least it should be 1. So negative 9, negative 7, negative 5, all these are odd numbers. Even numbers, when we divide by 2, the remainder is again 0. So far we have listed numbers inside the braces to specify sets. But also there's a way we can write it. This is called a set builder notation. So if I have X values or have a prime numbers, I can say X, the X will be our variable, and the vertical line, we read it as such that, so we say X such that the rule, X is a prime number. So this is a set builder notation. So instead of writing the prime numbers, maybe 2, 5, 7, 13, we can again specify the variable, then the number is a prime number. So this will read as a set of all numbers S such that S is a prime number. That means the answer will be 2, 5, 7, etc. Now we also should know what is a rational numbers. So rational numbers are normally fractions that have integer numerator and also non-zero integer denominator. As we know already in basic algebra or arithmetic, dividing any number by 0 does not give us an answer. It's an error. So that's why we say the denominator should be non-zero integer denominator. Now, using a set builder notation, we can write the rational numbers as a divided by a such that a is an integer, and we make sure b is a non-zero integer. We can't use zero. So rational number, in short, we say they are fractions. We have the numerators and denominators. So example is given here. If I write 5, the rational number of 5 will be 5 over 1. 3/4 will give me 0.75. Negative 1/3 will give me negative 0.33, etc. Also, we say some numbers have a decimal forms that neither terminate nor repeat. So a very good example would be square root of 2. There's an n, 1.414213572, and keep going. The power number also is an example, 3.141592654, and keep going. So some numbers have a decimal form that they don't terminate or they don't repeat. And also a union of the set of rational numbers, that is the terminating and repeating decimals, and the set of irrational numbers, that is non-terminating, non-repeating decimal, is a set of real numbers. And we'll see an example of this, which is a set of 4 decimals. So a real number is any number that is a rational or irrational. And using a set builder, we say x such that x is a rational or an irrational number. And these are the figure here shows all different types of number system. So we can see example of real numbers, rational numbers, irrational numbers, integer. Integer can be both positive and negative, including 0. Then non-integer rational numbers, make sure the denominator is not 0. Negative integers and whole numbers, 0, or non-natural numbers, as we said earlier, always start from 1. Integers will start from 0 and negative value, it doesn't matter. The whole number will start from 0, so there's no negative. Then we have negative integers, which is only negative values. We do not have negative 0. 0 is 0. So this is what we cover for now, the real numbers, different types of real numbers. Let's see an example here. They say in the set, a set is giving us a list of items. We should list the even, prime, and rational numbers. So let's look at the set. What numbers are prime numbers? And what numbers are even numbers? Even numbers, we know, is -2, 0, 2, 4, and 6. So -2, 0, 2, 4, and 6. Prime numbers means that it's only divisible by itself and 1, or the factors will be 1 and the number itself. So here we know 2 and also 5. Rational number means, again, we have a whole numbers, but it can be negative, 0, and the rest. So we get -3, -2, 0. Half is a rational number because half can give me 0.5. The decimal terminates. Then no, this is not. Then 2, 4, 5, 6 are all rational numbers. Irrational number will be square root of, irrational number should be a fraction. We don't have 1 here. So the next is identify properties of a real numbers. We did this, for example, if I have a plus b, a can be any value, b can be any value, but a plus b is equal to b plus a. It doesn't matter, 2 plus 1 is the same as 1 plus 2. And a times b is the same as b times a. So 2 times 3 is the same as 3 times 2. This is called the commutative properties for both addition and multiplication. We also have the associative properties for addition and multiplication. So if I have a plus b plus c, we're just going to change the values in the parentheses. So we can have b plus c in the parentheses plus a. Same thing, a, b, c. We can say b, c, a or a, c, b. AC will be in the parentheses term. So the answer will be the same because it's multiplication. Also, we have the distributive properties of multiplication over addition or subtraction. So if I have A, parenthesis A plus C, we can distribute the A to both B and C. So it will be A times B, which will be AB, plus, we keep the symbol plus, then A times C, which will be AC. Or if it's subtraction, the same thing, A times B minus A times C. Negative rule, double negative rule means we know negative times negative will give us positive. Positive times positive will give us positive. But negative times positive or positive times negative, again, will give us negative. So double negative rule always will make it positive. Then here we're going to determine which property of a real number justify each statement. Again, determine which property of real numbers justifies each statement. So we have 9 plus 2 in the parentheses plus 3 equal to 9 plus 2 plus 3. And we also have 3s plus y plus 2, which is 3s plus 3y plus 3 times 2. Now the question says we should determine which property of real number justify each statement. When I look at A, I can see the parenthesis value changes. So if you remember, and also it's addition. So the answer will be associative property of addition. Here we can see that we multiply 3 by everything in parentheses. So this is like distribution. So we are using the distributive property. So B is using distributive property. A is using, again, associative because we are changing the values in the parentheses. And the last section will be the graph subset of real numbers on a number line. A number line normally will be horizontal. We know the middle is 0. To the left will be negative. To the right of the 0 will be positive. So that means the value increases to the right and decreases to the left. So they gave us an example that we should show the graph of a natural number from 1 to 5. So I'll just have the dot 1, 2, 3, 4, 5. So that will be my graph. Also shows the graph of a prime number that are less than 10. So I don't want to go more than 10. 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, 8, 9, 10, they are not a prime number, they are composite because it's divisible by 8 and 1, but also divisible by 4 and 2. Divisible by 1 and 9, but also divisible by 3. Divisible by 1 and 10, but also divisible by 5 and 2. A prime number is only divisible by itself and 1. So for example, 7 will give me 1 and 7. 5 is 1 and 5. 3 is 1 and 3. 2 is 1 and 2. So 1 and itself. And 9 will be 1 and 9, but also 3 included. And this is another graph from -4 to 3. So I know 0 is in the middle. To the right will be positive value. To the left will be negative value. So from -4 to 3 will give us this graph. Also, we can show the graph of a real numbers, -7 third. First, I'll try to get -2. Remember, -7 third will be like 2 point something, 2.3 or 2. Then we have -3/4. -3/4 will be -0.75. So should come before -1. To the left, the negative value increases. To the right, the positive value increase. When positive value increase, the value become bigger, more higher. But negative value, when it decreases or the negative value increases, it decreases the value. So the smaller, for example, -200 is smaller than -2. So this is another question given to us. So all we need to plot We plot the horizontal line, then we know which value is less, which value is high, then we plot it. So we have -3, -4/3, we have 0 value, and we have square root of 5, which will be 2 point something, so a little bit over 2. So this will be the conclusion of our first lectures in college algebra. And this is again is a review, basic algebra review. Thank you. So see you in the next lectures.